Hello and welcome to the Nova Show. Welcome to the show, everyone. Hello and welcome to the Nova Show. The show where I do what I want when I want because it's my fucking show. Today on the Nova Show, we're going to be looking at TCP. All kinds of TCP. We're going to be looking at TCP in C. We're going to be looking at TCP in the kernel. We're going to be looking at TCP on the wire. How's everybody doing today? If you're new to the show, welcome. If you've been here before, welcome back. If you don't know what you are, welcome to the party. I'm your host, Chris Nova. What's today? Sunday? Happy Sunday, everyone. How's everybody doing? I hope you're all having a wonderful Sunday. Is that true? You guys having a good time? You guys and gals? Guys and gals and thems and theys and everybody else? Let's see who we have here. We have Jabu Bob is here. Good morning. Bliss Up says she's back and gave me a sub. Thank you. Thank you, Liz. I appreciate it. Adiusa, good to see you. Yes, Just Wolf is here. Yes, Just Wolf. I guess it's Just Wolf. Is that what we should call you? Yes, Just Wolf. Okay, Wolf it is. Who else do we have here? Adiusa. Gannett is here, says good morning. Mouse Me says good morning. Good morning, Mouse. Laser Bacon. Now that's a fucking name. Gotchigasm. I don't even understand what that person's saying, but I like it. Sorry. This is the part of the show where I stumble reading people's internet names. NOTST3_, or in Elite, I think that would say Notest. Says Switch's desktop. Ascertainment is here. It's good to see you, Ascertainment. Gannett says doing great. Just taking a break from this VM troubles. No worries. Morris Tolly says good morning. Adiu says a little bit tired, but happy you decided to do a show. Thank you. I thought about doing a show yesterday, but I had other things I had to take care of yesterday. But yeah, I hope everybody's having a good day today. I hope you're all having a good day today. Good afternoon for me. I hope you're having a good day too, Chris. Thank you. I appreciate it. So, we are going to be looking at TCPjack, and we're going to be drinking coffee and saying good morning. I haven't really had anything to drink yet today, so first some water. And next, my big oat milk latte that I make. I make like a quadruple extra shot oat milk latte. Okay. So who here has been following along with the past few streams that I've done? So like to catch you up to speed, here's what's up. So I was very active on the internet. I was streaming. I started Hachyderm. We built a Discord community. There was all this cool stuff that happened. I decided to take a break. That was a good idea. I wish I would do that more, and I wish I was still on my break, to be candid. And I learned a lot about myself and the internet and the human condition, and came away with a deep infatuation with this concept known as ego death. Needless to say, I won't be back on social media anytime soon. However, I do have all of the social medias at my disposal, and deliberately not using them and practicing self-control. Now that is a tune we can all dance to. You want to feel good about yourself, go practice some self-control and know that you are the only thing in between you and what you're trying to do, and you're telling yourself no. That will make you respect the fuck out of yourself really quickly. And candidly, if you respect yourself, it shows. It makes you very attractive. People notice it right away. So it's pretty cool. So anyway, so there's that. When I came back from my break, one of the things that's been stressing me out is I haven't been working on Aura as much as I would like. But I did want to start streaming again. So I don't know what it was, but I got the little feeling in my jellies that I get whenever I have an idea. And one of the things that I wanted to do was start doing some TCP instrumentation for one reason or the other, or just understanding tracing in general at large. So anyway, I started working on this new tool called TCPjack. I don't expect it to actually be used for anything other than it's just a research project for right now, which is how most of my tools start and how most of them die, which is good. Tawny is back. Hold the fucking horn, everyone. So Tawny's back. Tawny gave me a sub, and I appreciate it. And it's good to see you, Tawny. Laser Bacon gave me a Pepe clap. Feel Strongman clap. Got it. So anyway, we're going to be looking at TCP today. So regarding TCP, my thought was that we would be able to instrument the wire. So there's this term in computer science often referred to as the wire, which is basically layer 2 and layer 1 of the OSI model, if you're familiar with this. And I put together this blog and a small thesis on what I was going to try to do, and today we're going to be hopefully making some improvements to a tool called TCPjack that I started. So, a couple of things I need from you all at home if you're watching. So, number one, I need you to go familiarize yourself with the tool so I don't have to go and do this really long diatribe like I did last time. So the link is here, and we'll just gloss over the blog really quick. We'll just skim it even faster than we did last time. So there's a link here, and actually I just put this blog we're looking at, it's on Hacker News too. So if you want to go and if you want to give me like a quick thumbs up on Hacker News, so other people see this, I would be curious in feedback. So if you want to go drop a comment or a like here, I would appreciate it. And I think somebody already put it on Lobsters as well, and I suspect it's just a matter of time before one of you here goes and drops it somewhere on Reddit. So anyway, here's what we're looking at today. It's not necessarily anything new, although it is kind of new. It's a new take on an old concept. It's like going to Chili's. You still get a cheeseburger, but if you go to Chili's, you get a jalapeno zinger coconut rum cheeseburger, right? It's just a new take on an old concept. So anyway, we're going to be looking at network instrumentation. So the blog talks a lot about instrumentation in the kernel, which is what I do every day at GitHub. So basically it's like blah, 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 GitHub is slow. I want to make GitHub faster. I used eBPF, blah, blah, blah. Hey, that's a really good idea. Instrumenting the kernel is helpful. I like this tactic. This is a good idea. We should do more of this. I wonder if we can do this in other places. Hark, can I just instrument the network itself the same way that I instrument the kernel? And so I kind of talk about like, I wonder what that would look like. And I wonder what types of signals and metrics I could get out of that. And so very quickly, the first thing that came to mind was traceroute, which show of hands, who here does not know how traceroute works? I want to know if I need to go and just like give the 5-minute overview or not. So I'm just wondering if there's anybody brave enough to put their hand in the air and say, Nova, please explain traceroute to me like I'm 5. Adiusa says me. Okay, so basically here's what happens. You have a client, in our case that will be like Emma here. And we have a destination. So let's say destination is google.com. And we want to trace the route to google.com. So all we do is we send a specific type of packet over to the destination. However, in each packet that we send, we have the ability to set this thing called a TTL. Who here has heard TTL before? I suspect a lot of people have heard TTL before. But in case you haven't, it's a member of a TCP header, or sorry, an IP header, not a TCP header. It's here. So on line 208, you see we have this TTL here. So I could set this to anything I want. I could set it to 12. I could set it to 8. Some integer value, basically. I could set it to 0. I could set it to, you know, any valid integer. You know, I could set it to 1,000. In our code, though, it doesn't matter what that is doing today. What matters is that you see that it's just like a struct member is really all you need to know in the packet. Okay? So we set our TTL. In this example, we set it to 2. See? TTL is equal to 2. And every hop, it decrements by 1. So the first hop at this alpha router, we're left with TTL equal to 1. And then at the next hop, we're left with TTL equal to 0. And that router will drop the packet. Now, most routers are programmed according to the standard. Not all routers, but most of them are programmed with the standard. Whenever they drop a packet because of TTL, they send an ICMP response back to the client. And the ICMP response traverses the network, presumably in the same way it came, but not always. And it goes back to the client and basically says, yo, bro, I dropped your packet. And here is the name of my router. And that, friends, is how we get the name of the router, is we programmatically, we set our TTL to 1, and we get this router, and we set it to 2, and it'll make it 1 step further. And then we set it to 3, and it'll make it 1 step further. And then eventually it arrives at our destination, and we get a valid response. And that is how you trace a route. Does that make sense? Does everybody understand that? Everybody understands that? Yes? No? Maybe? I'm going to say yes. I'm going to say we all understand this. Fail plus is, unfortunately, this is like reading a foreign language without a cognitive stimulant. I don't understand what that comment is supposed to imply, but hopefully it just means you need more coffee. In which case, cheers. Coffee time. Router is a frat bro. Got it. Yes, every router is a frat bro. And if you look behind me, we have plenty of network hardware back here we're going to be debugging on today. Okay, so that's how traceroute works. Now, what traceroute does by default is it uses UDP and ICMP echo packets, complete with a time to live value set. Now, this is where we are going to be doing things different. Remember I said it's an old concept with a new take? Okay. I want to be able to perform a similar exercise, but with different types of packets. So here's the theory, and there's not very much data on the internet, so we're going to be going and building our own data set today. Can we do this with TCP? And the answer, of course, is yes. And let's see, here you go, traceroute and TCP, okay? So TCP is what the vast majority of internet connections are made of. In fact, if you're watching me on Twitch right now, you probably have several TCP connections open just to watch me on Twitch, whether you're on your phone or your computer, but there's certainly at least one for the browser, if not a handful. And there's an RTMP stream, which is built on, I believe RTMP is UDP, but regardless, there's going to be a lot of TCP connections. Anyway, so you can do this with TCP send packets. Now, this is what we're going to be building today in a few minutes when we start looking at my code. Basically, we're going to be prototyping what exactly does this send packet need to look like in order for us to get this ICMP response back from a router. So we have a little lab set up and we're going to start tinkering around with C code and running some code and seeing what ends up happening. Okay, so anyway, you can go and you can read the rest of the blog, and it talks about, you know, how all of this works. It talks about why I want to measure latency, and it talks about this thing called TCP hijacking. We're going to gloss over this for right now. Basically, all you need to understand is doing some kernel hacky shit. I have been able to successfully steal a TCP connection off a computer. So what does that look like? When I say steal a connection, I'll show you. So let me build my program. So let me just show you a command that most of you will know, or what is it? Not AS, SN. Let's just do netstat grep-i stab. There we go. And then we'll grep-i TCP. Here you go. So on your computer, you can look for TCP connections. Here. So everything below that line is what we're looking at right now. And you can see there's a lot. We have TCP connections open to EC2, which is in Amazon. We have them open to some CDN. We have them open to Macromedia Flash in San Jose. We have them open to all kinds of shit all around the world. All around the world. PR chat user, that's probably my chat. I'm assuming some of this is Firebot, some of this is Twitch. There's a whole bunch of stuff going on my computer right now. In fact, I encourage you to go and look on your Linux computer, because you all obviously run Linux. Otherwise you wouldn't dare be here watching my show, because you would actually be out enjoying your long weekend with your friends and your family and your thriving social life. So anyway, we have all of these connections. So what I was able to do is I'm basically able to hijack one of these connections. Okay, so I'm able to come in and say, you know, this one here, I want to go steal it and I want to fuck with it. Okay, so what I have is this command called TCPjack, and if you compile it and you run it, you can see it's just a normal CLI command. And I started writing this a couple of weeks ago. So if you do TCPjack and you do TCPjack-L for list, it'll list all the connections that we can jack. Yes, and so NOT says if top is another one. There's a lot of ways you can do it. You can use SS as well. So if you're familiar with FS, you can do FS grep TCP grep stab, and if we zoom out, you know, we can get it all on one line. Probably. Let's see. Nope, it does multi-line printing. But here you can see that this is another one, right? And these are all of our local TCP connections here. Okay. So there's a lot of ways you can get this data at your computer. So if we do TCPjack-L again, you can see we have this nice color-coded output here, and it'll show you the source address and the destination address. Okay. Okay, so anyway, so what we have here is you can see these are all of the processes and PIDs that come with my TCP connection. And you're like, wow, Nova, that's really fucking useful. Have you ever been on a computer and you say to yourself, man, I want to know which process is listening on which port, right? Well, this is kind of like that. This is like, I wonder which process has an open TCP connection somewhere else. So given a computer, I can go and I can list and I can see all of the processes that I have open, and I can see the actual TCP connection. So every TCP connection has a source address and a destination address. SATR, DATR. SATR, source address, DATR. Destination address, destination adder, DATR. SATR and DATR. So we have SATRs and we have DATRs. And so that's what I call them in my brain. If you don't like it, fuck off. And so anyway, for our source address, we will mostly see this 10.0.0.100, and we'll mostly see this 127.0.0.1. So this is localhost. We all know that one. And then this one is just my local IP address. So it's going through my router. It's doing some NAT traversal or NAT translation, and then it's ultimately traversing the internet and hopefully arriving at our destination over here. So if I wanted to instrument, say, like this Discord connection, what I would do is I would take TCPjack and I could say TCPjack, and I grab its inode. So this is this yellow column here. This is the value that you want to use. And you paste its inode here. And of course, if you enter the wrong one, it'll yell at you and tell you how to fix it. But like, you enter that one there, and if you do it correctly, it'll just hang, because it works basically like netcat. So like what we could do is we could like echo like failure or anything really. We could echo an encrypted string if we had the key here. And then we just pipe it to TCPjack, the name of the inode. And you can see here, if we list again, so we were using this inode here, the 66348, and the 66348 was somewhere up here. I think it was Brave, I want to say. Here it is. It was Discord. It was this Discord one. We shouldn't see this anymore. So Discord, we just broke the Discord server. Yeah. So Discord opened up a new one, but basically we just killed that TCP connection because we hijacked it and sent a bad message across the protocol. So TCPjack would be useful if you want to take over a TCP connection, if you happen to be able to form the right message that the protocol accepts. And that's about all that I wanted to build for that flag. Okay, so we have this Jack flag. So this one is pretty much done. This list flag is pretty much done, right? We all remember I was able to list all the connections, and we know that we're able to jack a TCP connection using that way. So this is the one we're working on today. Trace. And this trace one might actually be out of scope for TCPjack. However, we're going to keep building it here because it's where all my code is. I might pull the flag out later. I'm not really sure. So what Trace is going to do is Trace is going to try to do this, but with TCP send packets. And that's what we're working on today. Any questions? How did I do on time? Last time that took like an hour. I think this time I did it in like 10 minutes. So hopefully that worked out okay. Any questions, or are we all good? Cool. I'm going to say we have no questions. So let's get to the code. So what we have here is we have my source code, and we're going to be looking in goodhere.tx. Cool. So we're going to be looking at this trace.c. So I left off, I was just noodling on this last night, and somewhere in here, there should be like a left off here. There we go, left off here. Cool. So there's a couple of things that I want to do. So I'm going to actually add some to-dos to the top of the file here. We'll go all the way up to the file. We're just going to add some notes here. So we want to do, we will say correlate statter source address to interface instead of guessing. And we'll say to do correlate, let's see, correlate packet to PID during initial snoop. Okay, so that's what we're going to be doing there. So this is a fairly involved system, and I've refactored it a few times, and we're likely going to be refactoring it again today to really get it right. However, we'll get it. I had not a doubt in my mind. How do you know which port to trace route for? So that's a good question. Basically, given a TCP connection, we can find the process. Given the process, we can find, well, given the TCP connection, we can find all of the source address and destination address in a file called procnet TCP. So on your Linux computer, everybody here is familiar with proc. This is where I'm getting all my data. This is also where all of the if config and IP command and netstat and ss, all of those commands get their data from here as well. It's all the same. It's all just funny money. It's all reading from the same place. AppArmor protects this, right? I don't know if AppArmor protects this. Maybe. Does AppArmor? Let's go see. Let's go. I can tell you really quickly. Let's go see. Let's see. AppArmor. And then we want to do, this is git. Wait, no, it's PID-fd, get-fd. Let's see. And we want to put this in quotes. So it's PID-fd. So PID-fd open signals. Yeah, so it looks like this AppArmor profile, whoever this guy did for Builda. Provide AppArmor profile for running inside a Docker container. Yeah, this one would prevent it. No, this is just the patch. Oh, here's a good blog on bypassing eBPF security monitoring. Here's a good blog. I don't know. I think you would have to configure AppArmor to look for that specific system call. It's a newer system call. It came out in 2020. Which we all know that was like yesterday because the world froze in 2020. Anyway, I don't know enough about what AppArmor ships with by default to answer that question. However, it's not impossible to like prevent this. Like this tactic is like this is about as dangerous as like SUID exploitation or privilege escalation, if that makes sense. Like it's a well-known thing in the kernel, and I doubt any serious security vendor out there would let you do something like this without some event or something being triggered. Most of my code here is extremely invasive, and I'm not doing anything to try to cover my tracks. So like this isn't like a go try to do like sneaky stuff kind of code. This is just like, I'm running this tool called TCPjack and I'm gonna go do all the shit I want to do, and I don't care if you see me or not, for what it's worth. Okay, so anyway, I digress. We're gonna be breaking into a few functions here in my code. So we have this trace TCPcon connection. So this is where we're going to be doing most of our work today, the main tracing system. Okay. So the first thing we do is we find a device, and this is where that to-do was that I put earlier. We'll have to correlate this device to, I guess I can just do it really quick, and dev adder net mask. Say correlate dev IP to SATR IP. So how do we find our dev adder? Let's see this. So and dev adder dot sock adder net mask destination adder. See, we're gonna have to do some translation. I don't think we need to do it right now, but we'll keep the to-do for now. So the one that I really want to work on, because the reason that this one doesn't matter for right now is because I only have one interface on my computer. So I know my little algorithm I wrote here earlier will just pick the right interface, so it'll just work for right now. But like to make it more robust code, we should really like actually have it map up, if that makes sense. Okay. And I just don't want to deal with it right now because welcome to the Nova Show, the show where I do what I want when I want because it's my fucking show. Okay, so let's see. So found a TCP packet and to do left off here. So what we want to do is we want to compare our IP packet details to what we know is in proc. So this section is all, I'm coding all of this with the presumption that we need to find the sequence number of an existing TCP packet. Why do we need the sequence number? We need the sequence number of an existing TCP packet because we need to set the sequence number -1 to send a keep alive packet. So how do we get the sequence number of a TCP packet or of an IP packet without disrupting the current connection? We're not going to be able to disrupt the connection. That's like the whole thing, right? Like we're instrumenting it. We can't break it. So how are we going to do that? We sniff it off the wire. We get it directly off the device driver. We don't get it from the fucking file descriptor. We have the file descriptor. We could just file descriptor.read, but we're gentlemen, so we're not going to do it that way. We're going to read it off the wire, like proper grown-ups. For now, the term is used a lot in development. In my experience, most of the time, it's permanent. My brain is just, it's Sunday. I don't have to go to work. I'm drinking coffee. I'm hanging with my friends on Twitch. We're having a good time. Ever used SCTP? Secure CTP? I don't know. What is SCTP? What is this? Thanks for the sub, Laser Bacon. I appreciate it. Okay, so let's just debug this out for right now. What do y'all think? So we have our TCP header. So we have our Ethernet frame, and then we grab our IP header. So let's just print our thing and see what we get. So printf. So we want to grab a string, and that's gonna look like, this is not IP. Is it IP? That's an IP packet. I want a TCP packet. So it's TCP. Here we go. Oh, that's the RAID sound. So what is TCP sequence? What type is this? This is a, not printf, I want sequence. Let's go see. TCP header sequence is, what are you? UN32. Unsigned integer. What's up, Theo? How's it going? Welcome to the Nova Show, the show where I do what I want when I want because it's my fucking show. How are you, Theo? It's good to see you. For those of you who aren't following, if so, I suspect there's 4 types of people in the chat. There's number 1, there's cybersecurity people who want to see how to steal TCP connections because they want to be hackers. Number 2, there's network people who are the most underappreciated and underpaid people in the tech industry, but also the most badass people in the tech industry. Who are just here because they think it's cool. Number 3, there's people here who like have some sort of LGBT trauma and they just want to see a successful queer trans person and they're just hanging out because they think it's cool and they're looking for something to do on a Sunday. And then the fourth type of people here are just here because they have nothing better to do, and I haven't like taken away their like small ADHD window just yet. So if you're in group 1, if you're in the cybersecurity group, or any of the groups, let's be candid, but mostly for group 1, go follow Theo. That guy is fucking awesome. He is chill, down to earth, super smart, and he hangs out and does these really fabulous, slow, chill, very welcoming, I would even dare say the word wholesome streams where he goes super deep into all kinds of cybersecurity tooling, and he's bettering himself on Twitch week after week. I've been lucky enough to watch him grow over the past year, and he's just a super awesome person. And you know, when you have these remarkable people like Theo, their community is going to be equally as awesome. So stop what you're doing and go drop be Theo a follow. If he was streaming when I got done, he would 100% be the person I would be rating, and the guy is super awesome. So anyway, here, we're going to jump back into it. So for now, we're just going to break our algorithm and we're just going to print our sequence number and just see what we get. It might be gobbledygook, it might be not, but we'll jump into it. So let's get our bash commands up and running that we're going to be using. So we'll do make, and we'll do TCPjack-L. So that will compile our code and then list with our freshly compiled code. Okay, the other command we're going to do is we're going to do sudo e gdb TCPjack. We're just going straight into GDB today. I hope y'all are okay with that. Okay, and then quit, yes. Okay, so here's TCPjack-L. Great. And so we will grab Brave. We're going to pick on Brave today. And then we run our GDB and we do R T, and we're going to trace this in GDB and see what we get. We have to grab the symbols from all the other. There we go. Okay, so let's see what we got. This is all debugged from the rest of my code. So here's an ICMP packet from .60. Here's another one from .1.14. None of those look like my router. Holy shit, it is a noisy, networky day here on Sunday morning at the Nova house. Wow. .54. We're gonna have to break our code to debug this. ICMP is loud. Well, these are all non-ICMP packets. So let's do this. Okay. And we will exit one. We're just gonna break here. Okay. So we'll make and we'll list. We'll grab an inode from Brave and we'll T this and see what we get. Oh, RT that. There you go. Cool. Look, so we did get that looks like a sequence number. That is a sequence number. Cool. So it is working. So that's good. So let's get after it. So what we need to do we're going to do some correlation today, and we'll simplify our code later. So if we'll say we compare our, let's do this. So we know our proc entry. Where do we get our proc entry from? It comes in somewhere here. TCPcon is in TCPcon. TCPcon.procentry. We have a PID, we have a COM, and we have a jacked FD. So we have this information as well. We have remote port, remote adder, local port, local adder. And what do we have in our TCP packet? We have TCP. We have source, we have SYN. I guess we want the IP. We want IP because we're at layer 3 right now. IP is layer 3, right? I said that right. Data, destination address. Okay, so we'll need to do data to data. So let's draw a picture. This is like my thing. I at one point fancied myself a physics major before, and then I realized college cost money because of capitalism, and so I no longer was a physics major. However, when I used to daydream about being able to afford to pay myself to go to school, I used to love watching physics lectures. I used to torrent physics lectures on, so I worked at a bar on college. I didn't go to college. I worked at the bar on campus and made money at the bar. And I would go and steal college internet, and like I would go sit down in like the cafeterias, and they would have these internet ports that were active and hot, and I would absolutely go just fuck with them, and I would just go and sit there and just steal free internet and just torrent college lectures. And there was this one physicist I used to watch, and his whole thing, he was always like, when in doubt, draw a fucking picture. And like to this day, like as a computer scientist, this is all I talk about. I'm just like, stop what you're doing, stop guessing, go draw a picture. And so anyway, we're gonna draw a picture. And like shout out to my like whoever that like Missouri, Iowa State, whatever like college professor was from like the early 2000s. So anyway, so here's our packet. Okay, so we have an incoming packet. It's coming into our local interface, and then it's got a destination adder. Okay, and then here is where the kernel checks the IP. Okay, so the destination adder is what we want to correlate against the TCP address, or the TCP packet, or sorry, yeah, TCP packet. What did we get? TCPcon. Local adder, remote adder, local adder. Inbound TCP packet, and then we'll say listening TCP server. So this will be local file system, and then this will be its, let's see, that is our local adder. Okay, so these are the two things we want to compare. We want to compare the destination adder to the local adder. Cool, and we have a TCPcon, and we can do this because I wrote good code. TCPcon. Local adder is a struct in adder. Cool. So that's an internet adder, and then a datter is a uint32. uint32. Cool. So this is a uint32. H2NS? What's the function we're going to use here? How do we get a uint32 to in adder? I think it's H2NS. Sock adder. Oh, we can just do it this way. Okay, so, okay, cool. So we will say we want to compare the inbound data to the local adder. Okay, so we will need the it will be an in adder inbound is equal to, and then it's source adder. God, this is going to be so confusing. IP data. Cool. So then now that we have two in adders, we can do a compare to compare. And I guess we don't even really need to do that because we can just do a UN32 compare. Yeah, let's do that. UN32 to local adder UN32. That's the common denominator. So we can get rid of this line and let's do, oh goodness gracious, if here. Is that better for folks? Okay, so so let's get a UN32 of our destination adder on the inbound packet. So that's IP data. That's a UN32 equals, okay, help me out here. TCPcon, it's not a pointer, so local adder, and then there should be a nested sadder. That's a UN32. A sadder. So you're an in adder T, which is a UN32. And so that works. We can just do that. That's our check. Now that's a fucking check. You know what? This is my favorite. What's one of my favorite fucking things about C? You'll sit here and you'll think about it for like 20 minutes and you'll go through blah, 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 blah. And you're like, man, I got to compare this to that. It's big, it's complicated, it's messy, it's dirty, it's C. It's log. And so and then you get done and it's just like an int to an int compare and it's like 4 lines of code and you're just like, what the fuck? But it's just like this huge, big, complicated thing. But because everything is just like native types, it's always just like int to int or just like a string compare if you're really lucky and you have to like use a little bit of memory. But other than that, it's just like really straightforward. I don't know if that's good or bad. It just makes me happy. I'm not writing very good C right now, but like in my prime, I used to be able to just like fly through this stuff like super fast. Okay, anyway, so Vancouver says, good morning, Nova in chat. Happy weekend. Happy Vancouver. How are you weekend? You can view a list of commands here. Uda is here. Dances with dirt. That was neat if anybody's interested. Cool. I realize I'm not reading a lot of the chat, but y'all feel free to introduce yourselves, follow along. One of the things I actually need while we have a bunch of people here, if we have any mods or any volunteers, I need a new Discord. We need to set up a new Discord. So there's a lot that goes into this, right? However, if anybody is just like really just wants to like just volunteer to just go set up a new Discord and like help get the Discord online as like a temporary mod or temporary admin, feel free to go ahead. We have like branding guidelines and everything we can give you. I just need somebody to help set it up, and we need to get a new one up and running. So anyway, if you're interested in doing that while I'm streaming, feel free to just volunteer and let me know, and I'll single you out and we can get one going. Anyway, this goes back to the whole like we keep sending people to the Nimedly Foundation Discord problem. So anyway, so here's our check. So if IP data is equal to local source adder, so then we print our TCP sequence, and then we do searching is equal to 0, and then we're just exit for right now because we just want to make sure our code works. Okay, so let's format our code and then let's run it and see what we get. So let's grab an inode from Brave and we will RT this. I don't know why it keeps debugging this. Look at that. We actually found one. Cool. So we found our sequence number very quickly. I can't believe that actually fucking worked. So let's move this. let's move all of this. See you around, BTO. Thanks for hanging out. Okay, so we'll need to do a timeout here. So how many packets do we want to do? Let's do we'll define it up at the top. We'll go code this the right way. So let's do a pound define all the way up at the TP top, and we'll add a comment for it. So we'll do this. Let's comment this one. So this is the pcap device capture filter to use for sniffing during a trace. This will filter all packets for both the initial lookup, the initial sniff, as well as the sniff for trace replies. We'll say changing this will impact all packets. There. Okay. So there's that. So let's do another pound define. So this one will be initial capture timeout packet count. Oof, that's a good name. And we'll set this to 256. That's quite a bit. How noisy do we suspect a network to be? That's probably good. That's got to be fine. Do we want to do 512? We'll keep it with 256. We'll change it if people actually start running my code. We can change it. Okay. So this will be during a trace, we sniff a single packet off the wire to learn about the existing TCP connection. In order to find a valid packet, we must sniff all packets that make it through the initial filter. This count is how many packets we can sniff before breaking the tracing system and terminating the program. Okay, so let's go and code it now. So where were we? Sniff a packet off the wire so we can find a sequence number. So we will do int timeout is equal to, what did I call that? Packet. This thing. There we go. Cosmo Jaeger, what's going on? Welcome to the show. Timeout. Okay, so while searching, cool. So we will say timeout plus plus. So we'll say if timeout. Actually we'll say timeout minus minus. And we'll say if timeout. I know this could be a for loop, but we'll keep it a while loop for now. It doesn't really matter. If timeout is equal to 0, exit, we'll give this, so I don't know, 55. Cool. So my strategy whenever I write C, you guys, I always just do printf just to get started because it's the fastest. And then once my program is in like a good state, I'll go through and I'll do all the error plumbing and all that later. For now, when I'm just developing, I just printf, just keep it simple, and we can come back later and we can do all the error handling. One of the things that I really love to do is I love to find these low cognitive things that I can push off to later, right? Like instead of trying to like keep all the stuff in my head, like I need to go instrument the wire and find a packet and code this timeout system and do this and do that and do all this other junk, also go fucking code errors, right? It becomes a lot. So there's just printf, you don't have to worry about it right now, and then like smoke a joint, you know, pour yourself a cocktail, go sit out in the sun, you know, whatever your thing is, and then go to code errors when you don't have to think about it, right? And then it's just like more of like a Zen exercise and less of like a cognitive load. So this is just like an old programmer's like just personal habit here. Find all the Zen stuff and break it out and do it later. You know, that's almost a reward. I love cleaning up code. I make my comments pretty. I rename all my variables to match. I'll just zone out and just go do that. And it's like super cathartic for me. But I don't do that right now when I'm thinking. Now's not the time for that. We'll do that later. Okay. So anyway, so here's our little timeout system. That's another thing that I really like to do. I love to keep I know that AI is taking over the world. Trust me, I know. I want to keep the old habits of yesteryear, of the old world programming alive. So like one of the things I often think about is like, who here is into blacksmithing or any sort of like craftsman type work? So I like to do woodworking. I'm actually building like a 3-dimensional climbing wall in our garage right now. I do framing and electrical, but I also like really want to get into blacksmithing. I haven't touched it yet though. Like I'm like, I've watched videos, that's as far as I've gotten, but like at some point in my life, I want to build a forge from the ground up. And so a lot of these blacksmiths that I watch, like I really like the like Black Bear Forge. That guy's super tight. Anyway, one of the things that they're always saying is like, yes, I know I could go and like pour this as like using some sort of cast iron mold or something, but he's like, I just want to keep the old habits of yesteryear alive and just keep the tradition going and do things the old fashioned way. And like candidly, like if that's what happens to programming, I'm here for it. Like, I want to be like the old grumpy blacksmith of programming who's like, just write your printf statement, herpa-derpa, right? Like, I don't care because like this is fun for me. So anyway, things I think about while I'm coding. So anyway, so we time out, we break our code, and we have an exit status 55. Otherwise, we found a TCP packet. So we should, at this point, have packet header, and I'm gonna move these up. How do I want to do this? Can I access TCP here? Let's see. No. So what I need to do is this. And then we basically say there it is. Okay, cool. So we'll get the TCP packet, or the TCP header rather. And I actually think I want to rename this to TCP header. And we will call this TCP header. We also want the Ethernet header while we're in here, don't we? Why, yes, we do, Nova Pants. Yes, we do. So this will be ETH header. And we will call this our pcap header. Cap header. And then this will be our ETH header. There we go. We'll say ETH header and TCP header. Do we have the IP packet as well? I thought we had the IP packet. We do have an IP header. Wow, we have all kinds of fucking data. God, I love pcap. Wow, I love pcap. Okay. There we go. Look at this. The ETH header, we'll put it in order of OSI. So layer 2, layer 3, and layer 4. Cool, so ETH header, IP header, and TCP header is now available and guaranteed to be a sniffed packet from the hijacked TCP connection. So let's get those into our various contexts. So where's our context strokes? Okay, so we want to have... What switches do you use in your keyboard? Sounds like tactiles. Yeah, cherry blues. Okay, so let's see what we have. So we want ETH header. This is IP header. And so then we have struct TCP header. Cool. And so we will call this sniff. There we go. And we'll add this to both here and here. I think that's what we want. Is that your home lab behind you? Yes, yes it is. Meet Alice. Alice, who here wants to explain the stupid shit we've done with Alice? Nova Network. Meet Alice. She's got 48 cores and 126 gigs of RAM. She's an old x86 box. She's been through a lot of shit. If you've used Hackaderm before, the social media server, you definitely are familiar with this computer, whether you like it or not. Alice and I go way back. Alice she is an OG. She is an O-fucking-G. Anyway, meet Alice. She's behind me. We also have Yakko, Wacko, and Dot, which I think, if I remember correctly, Dot has memory errors or something. I don't know. They're just... We've been through some shit. So, anyway. Okay, so we have our sniffed headers in our various contexts. Let's go add those in the main tracing system. Where are you? Here we go. Here we go. Start to sniff. Sniff a packet off the wire. Cool, so let's grab. So we'll do sniffed ETH header is equal to ETH header. And we'll say sniffed IP header is equal to IP header. And we'll say sniffed, dot sniffed TCP header is equal to TCP header. And we'll copy all of this that I just typed. And we will put it here. And we'll do a make format, and hopefully it's all pretty now. Look at that. Cool. Okay, so there is spawn the emit thread, spawn the sniff thread, loop and sniff responses. Okay. So we now have our emission thread, which is emit trace packets. Okay. So we'll need to set our sequence number. Keep alive. So we're going to add, I can't believe I'm going to do this. Our sequence number is a UN32. so where's our packet TCP keep alive TTL? So this is a uint32t, and we will call this seek. Call it known seek. I'm gonna put this for both. I don't know which one it expects. And so we want ACK as 1 and SYN as 0. Okay, so that looks... So we'll say my research really is here. I am currently prototyping different permutations of a TCP IP keep alive signal. There you go. Okay, cool. So there's that. So let's start to try this out now. So let's go back to our tracing system here. So we know we need a keep alive TTL, and this will be our known sequence. So where in the fuck are we going to get our known sequence from? Oh, I have to go add it to the header, don't I? Hold on, everyone. So this was uint32 type. And what do we call this? Known sequence. There we go. And we go back to our tracing, and this should error now. So how do we get it? We get it from... This is our context dot sniff. Sequence number is in the IP packet. Why is my brain mashed potatoes? Why is my brain mashed potatoes? Sequence number, that's IP. It's in the TCP packet. Of course it is. TCP is a stateful connection. Okay, so... Where's my code? Hamburgers. I lost my code. There we go. It is in our trace.c. Okay. All the way over here. So context.tcp.sequence number, comma, I+1. Okay. Make format. Nice and pretty. So we have an error, and we'll debug our TTL. Okay. And then let's go to our tracing, and I'm going to get rid of our... We have this big system up here that does a bunch of debug that I was working on. We're going to get rid of most of this. We're going to get rid of this. And we're going to get rid of this. And this for now. Okay. Let's run our code. So make on TCPjack list. Oh, of course I have errors. Ether type. ETH is 278, 280, 285. 278. ETH header 280 and 285. Okay, so we'll grab a Brave inode, run our code with GDB. I'm so nervous. Y'all ready? Let's do it. Wow. Wow. Okay. So we emitted a bunch of packets, and now we're getting ICMP responses. Fuck yeah. Fuck yeah. Okay. And this one's from the router. Look, you guys, it worked. DMA is here just in time. DMA, we got an ICMP response from the router. You know which router I'm talking about. Hint, it did 1 terabyte of egress during the Hackaderm days. Are your dot files from your terminal styling in your GitHub? I can answer that question so many fucking ways. Are my dot files for your terminal styling in GitHub? No, they're mostly, my terminal is mostly just from cool retro term. If you run the term command in chat, you'll get what you need. My dot files are, I don't really have dot files. I do have a home repo that's private, but like I don't really use dot files for that much. I mostly just like, I have a whole bash home directory system that I like can easily download onto a local computer. I call it Novix, and most other people hate it. I happen to love it, but it's got all of my like goodies and secrets and everything in it. Anyway, that is stored in GitHub, but not the way that you think it is. But it also kind of the way that you think it is, but not like the way that most people do. Anyway, I digress. Okay, so we're actually getting packets back. So we were able to emit TTL packets, and we got packet. I'm gonna save this. Right. Wait, yes. So what we want to do is we want to get status, git add, git SSM, introduce seek number, and see from the router. Okay, code is saved. So if you want to see the project that I just pushed to, it's called TCPjack. That is on my GitHub. So TCPjack, it's here. There you go. Okay, cool. I slept on my neck all weird. I'm like trying to stretch my neck out. Okay, so let's go. Some loud ass crack. I also have a good ass mic. Okay, so we found a TCP header. Let's look at our sniff replies. Oh, and you know what I can actually do? I can get rid of this to do. Correlate packet to PID during our initial snoop. That's done. Correlate sniffed. Okay. So here we sniff the wire. And so here, let's see. So here's where we want to break into it. So we know we have an ICMP packet. Else, let's see what type of ICMP type. Let's non-TTL exceeded type. So this will be %s new line TTL. What is this? ICMP type. It's a UN, so that needs to be a U. There we go. Okay. Let's run our code. So let's grab an inode from Brave. And with GDB, RT this, yes. So non-TTL exceeded type 3. So these are all ICMP packets we're getting right now. So they're all type 3, which I suspect these are echoes. Let's go see. So we're getting type 3. Destination unreachable. And we're looking for these time exceededs. So these are all from me. Do we have any to me is the question. And why not? You need to grab the code to see why it's unreachable. No, well, yes, I understand that is why we would need to grab it to see why it's unreachable. I just don't think we care about, those aren't the packets we're looking for. So what we're doing is we're looking for packets coming to this IP address. Fair. And coming from a router. And so, and they should be TTL exceeded or time exceeded, whatever. They should be, according to everything I've read, they should be this type here, this type 11, this time exceeded. This is basically what happens when a TTL comes, expires. So I think we can just ignore them for now. A time exceeded packet. Okay, so I think that should debug them. So now let's turn on in our emission thread. And I can get rid of all this junk now. Rid of this. And this. So now we're basically just filtering for these time exceeded packets. Cool. Okay, so there's time exceeded. And that's all within the same block. So we can put that there. Return null. Okay, so let's go to our emission thread now. Trace packets, and I want to turn you on. Emit TTL packet. Okay. So quit. Yes. Compile and list. We'll grab a Brave inode. The more of these Brave inodes that I do that I don't break things and then I'm able to send all of the TTL packets, the more excited I get, because like we haven't been this far. I used to only be able to send one packet and then the connection would just drop because I fucked something up. But like now we're just like We're thinking about that. We're sending 32 packets across an active TCP connection, and the active TCP connection remains uninterrupted. Think about that for a second. That's cool. That alone is cool and exciting. Okay, I don't know what I did, but I broke something. Oh, sorry, you can't add flags. Okay, so there, and then RT there. Yes. Okay. See, broken pipe here. See, we got 2 packets sent, and it broke. So let's see, R-L. So let's try this one, R-T. See, connection reset by here. Broken pipe. Let's keep trying and see what we get. There we go. This one worked. Okay, so we sent 32 packets and then the thread exited. And we haven't seen it. And now we're waiting for replies. And we're not getting any ICMP echo replies off the wire. You can use gdb-args to add program args from the command line. Yeah, I think I just like doing it this way. It's just muscle memory is hard. Okay, I'm pretty convinced we're not seeing any ICMP packets worth listening to. Okay, so here's my new theory. We're fucking up something in our keep alive packets again. So back to the drawing board. So. Let's do this. Can you add anything to the printf output that gives you more information on what's happening each packet emit? Yep, that's kind of what I'm doing now. Basically, we'll break the thread if the connection errors, if our send to function errors. And we can see the actual TCP packet here. I suspect something here is... So we're doing sequence and ACK sequence. And we're setting ACK is equal to 1. So, I mean, we could try with... Let's go read about... So the ID of this packet. Like, I'm just wondering if we have to, like, add more... like, if we have to get more of these values, right? Proto-TCP. So, like, for example, right now, I'm just guessing the ID is basically 0. Like, that could be causing it to break. Like, I mean, it's just, who fucking knows at this point, right? Like, short of Wiresharking the existing TCP connection and looking at this stuff. DMA says, sequence should be next -1 for a keep alive, right? But the question is it sequence or is it ACK sequence? Because keep alive, you flip the ACK bit to 1. So should this be 0? Should I just generate a random one? I mean, like, should this just be the sequence number? So sequence.sequence equals sequence next minus 1 for keep alive. Segment sequence is equal to send next minus 1. So that would just be known sequence, known sequence. Then I still don't know if we put it on the ACK-seek or the seek. Yeah, I don't know about ACK-seek. It's fine. Okay, so let's compile and list. And we'll grab an inode. And we will RT this. There you go. Broken pipe. Fuck yeah. Awesome. Deep memory. Keep alive exploits that acts can be dropped, hence the reuse of sequence numbers to pretend it's just a resend, which suggests ACK-seek can be ignored. DMA to the rescue. ACK-seek can be ignored and sequence is known seek. So let's just try to get one. There might be another bug in my packet spoofing that's causing the some connections to break. I don't know. So we'll trace this one. It's time for everybody's favorite part of the show. Good morning. It's Sunday Twitch stream day. How long have I been streaming? About an hour or so. Let's see. It's an hour and 45 minutes. But it was a 30-minute intro, so about an hour 15. Oh, do you want me to come? Do you want me to come make lunch? You want? Okay. Let me wrap up my bug. DMA says hi. I actually don't know if DMA said hi, but he's here, so I suspect he said hi. Okay. Okay. Y'all have fun. Love you. Okay. Cool. Now I did. There you go. Okay. So let's see. So let's keep jamming here. So RL. We'll grab this one. Let's say R-T. Nope. So we're getting one packet and then we're getting a connection reset by peer. Okay. So that would imply we broke something here. Let's just try this with zeros really quick. And let's make and GDB. And we'll grab this most recent inode and we'll RT this. Nope. Broken pipe. No, we're still not getting any of them. So I used to have, let's go grab another one. So I used to do this H2NL0 here for ACK-seek. Is that what's going on? Is it's just a bad packet so the router's dropping the whole connection? So this would be known seek. Let's try that. Nope. RL. And we'll try this one. Nope, we're still dropping packets. Okay, so I see people in chat asking all kinds of questions. There was a question about Emacs. There was a question about, you know, dot files. There was a question about, I don't even know. There was another one like, how do I store my config? There's a lot of people like, hey, Chris, do you mind? I see Yusuf just put like a response to like a question earlier. I don't even know what the question was. I can't even find it. Do you have any advice for early senior level? I'm embedded software. Do you mind sharing the editor config? Sorry if this comes often. Okay, so there's a lot. Okay. I'd love to tell you all about career advice and Emacs configs and editor configs and all that. I really would. Now's not the best time for that. So it's a couple of quick answers. Okay, I'll just try to answer quickly because I don't want to get off topic, and so I don't want this to turn into like this big side fucking thing. I want to stay focused. I gotta go make my beautiful wife lunch. She needs salad or cheeseburgers or I don't know what I'm gonna make, but something delicious. So anyway, so if you have questions, get them in now because I'm gonna spend like 5 seconds per question. So let's just get this over with. So do you mind sharing the editor configs? Sorry if that comes often. So I'm assuming you're talking about these configs, these editor configs. I don't really have them anywhere. Okay, if you want to see what I have, come here to general, I think, or appearance maybe. I don't even know. It's somewhere in here. Appearance and behavior. Okay, so appearance. I use Lotus Dark. Screenshot this now because this is the best you're gonna get. So grab a screenshot. It's that little print screen button up by your keypad. I use Lotus Dark for my font. This is the other thing you want to do. For my font, I don't even know where it is. Source code variable. I'll also sometimes use this white rabbit font. You see this white rabbit? I'll use either source code variable or white rabbit. Okay? If you want to run term, you get my term. If you want to run font, you get my font. There you go. Boom, boom. Okay, next question. Do you have any advice on early senior level? I'm working on embed software too. If you're early senior level, I suspect the type of advice you're looking for is how to grow in your career. My advice to you is to start learning about scope and the business. Talk to your manager, ask to get more involved with like business decisions, start understanding how your org fits into the big broader company, and maybe even ask your manager if there's people outside of your group that you could just talk to for career advice. Finding a staff engineer or a principal engineer to talk to is probably a good thing if you can find one. As far as things you can do for yourself, I suspect getting to the point where you can code anything in the world. Meaning that the only thing standing in between you and what you want to build is time, not skill. You should have enough technical skill to where you can realistically sit down in front of a computer and build anything you want. You should be able to build a web page. It may not be good, but you should understand how it works conceptually and be able to basically like stumble your way through it. That you want to get to that level. Okay. Won't the sequence number shift? Blah, blah, blah. Do you prefer vanilla Emacs or Space Max? A noob here. Vanilla Emacs, I prefer. Deep memory, puppy, RFC 1112. DMA is leading. I have a slightly off-topic question. Do you prefer to learn new technology, books, or videos? I read books. If I'm learning tech, I usually start with books. If I'm learning rock climbing, I usually start with books. If I need to learn something very specific, I watch a video. Most of the time, I hate videos. But every once in a while, I do enjoy a good video. But very rarely. Most of the time, it's books. Y'all can't see this, but I have a whole library of books over here. I have books I can suggest. I have books about books I can suggest. I have books that talk about which books are good and which books are bad I can suggest. I love books. I read all the fucking time. Always read. Always be reading. ABR. Okay. Next, what is this text editor? I use C-Line. I think you can run editor, I want to say. There you go. Preferable language to someone to learn how to program code. So DMA says send something with no data or one object of garbage data and with sequence equal to TCP send next -1. What about the ACK packet, DMA? Do I need to flip this? We need to figure out if I flip this or not. Or not the ACK packet, the ACK flag. Cool. ACK should be enabled, says DMA. Okay, so we have ACK enabled. We have known sequence -1. I guess, how do you calculate a sequence number? I think you just add 1, don't you? The socket struct has send next in it. Okay, so let's go get the socket struct. I don't know if we have the socket struct, but we can probably find it. Okay, so let's go. Okay, so last call for questions. If anybody has questions, get them in now. I'm going back to coding soon. I'm not sure, but have you ever used Emacs on your streams before? Yeah, I use Emacs often. I usually use Emacs to write Bash. We're writing C today. I guess I could write C and Emacs if we wanted to. I'm just using C-Line because it's got all the good lookup key stuff. Okay, so trace.c. We want to get to, where's our main system? Sniff a packet off the wire. Okay, so we want to get, we said a sock adder. What is it? Is it TCP sock? Okay, so let's grab this. So struct TCP. Where is a TCP sock in Linux? Who wants to tell me where a TCP sock is in Linux? Here it is from 6.3. Let's see, TCP sock. Protocol.h. Protocol.h. Oh, that's in a member. It's TCP.h. Do I not have net? I net TCP.h, but where we're going, we don't need net. Net. Wait, what the fuck? It's Linux. TCP.h, bro. We need those fucking Linux headers. Is it really? Are we really not able to get the TCP socket struct from anywhere other than the Linux headers? That feels wrong. Include net TCP.h. You think it's net TCP.h? Okay. Well, there you go. No more Linux headers, so that's good. Okay, so let's go all the way down. Where were we? Right here. So struct TCP sock. Here it is. I don't see TCP sock in there. Let's go look and see. Let's go look and see. So we think it's here. Why is this? It's net TCP not found? It's not going to be include net TCP. I think it's Linux TCP.h. Misspelling sock. Let's go find it. Okay, so it's not in netinet tcp.h, but we do think it could be in Linux tcp.h. At least we think so. So we think there's TCP sock here. I don't see it. Definitely not there. Include Linux tcp.h. Not found. Do I need to build one? You're right, Linux it is. Ew. No, I saw that Linux tcp.h, but I didn't see it there. It's not in my Linux headers. I didn't see it there. Right? There's socket options. Sock adder. There's socket.h. BSD socket. There's TCP word header. That's not a user space API. This is what I'm saying. I don't think it's the Linux headers. Or not the Linux headers, but the Linux, you know what I mean? Not the actual headers, but a header file in the Linux source code for kernel space. Thank you, Viragi. So it's got to be, let's do this, tcp.h. Is it sock? So I'll stop confusing things. No, you're good. I mean, nobody knows. Nobody else has gotten it right so far. And to be fair, I mean, the kernel is what forms the TCP packets anyway. So the fact that we get send next from a TCP sock where the TCP sock is a kernel space only members, it makes sense. Doesn't mean we can necessarily can't use it here in user space, right? Like, it just means that most people are forming TCP packets individually in user space is what it means. Most people just call, send and connect and accept, like Linux wants us to. So let's go look at TCP sock header, actually. What is it? Oh, it's fucking huge. It's ginormous. Holy shit, this thing is ginormous. TCP sock. It's got an iNet, it's got an IC sock in it, it's got a nested TCP rack in it. Oh, it's got all the TFO, TCP fast open stuff in it, fucking socket cookies. No, I'm back in kernel instrumentation land right now. This is not a place I want to live on a Sunday morning. Abort, disconnect, quit, get out of here. So where else can we get send next? That's what she said, JK. 40 to 50 years of features in one struct. I know, it's so ridiculous. Okay, so TCP send next. So we can get, let's go back to our main tracing system here. We can get TCP header. We can get these values. Do any of these look exciting? This is from an incoming. I guess we don't know if this is an inbound or outbound port packet, do we? How would we know if it's an inbound or outbound packet? Let's add another check here and see if maybe that's what's going on. So, ETH header. So what does ETH header have? We really need to get our host and start doing host compares. We need to get our IP address. Source reset. I guess, you know what we can do is we can say, and he's so what is a data packet will have nothing flipped, am I right? What is TH sequence? Urgent pointer window. How do we, what's an easy way we can check and see if so next should be sequence in the TCP header and receive next is ACK in the TCP header. Okay. So we already have sequence plumb through then, and receive next is ACK in the TCP header. Okay. So what is a TCP data packet? What flags do we have enabled for a TCP? Sorry, it's ACK seek in the TCP header. So that means that for keep alive should set to ACK to 1 and sequence to T head seek -1. TH sequence -1. Okay, so it's ACK sequence in the TCP header. Okay, so let's do this. Where is our emission thread? Sniff replies. Here. So we're bringing in the sniffed TCP header. So DMA says is sequence. So we can pass in whatever value we want into the packet generation function. So we have the TCP header right here. So we can pass in. We said TCPjack was what? TCP sequence. There. No, I think you had it right. So it should be what you had. So yeah, I'm passing in the TCP header sequence number. Do we want to do TH? I guess that's just a type thing. So that's the sequence number. And then in the packet generation, we take the sequence number and we do known sequence -1. And we set that to TCP header sequence. And we flip ACK is equal to true. This looks right, doesn't it? Yes, I know. This looks right to me, says DMA. Are the fields in sniffed TCP packet in network byte order? But why H to long? I think this is just a way of ensuring that it fills out the bytes correctly so that we don't end up like this solves like the 0-9 problem and prevents 0-9 from turning into 90, if that makes sense. What kind of qualities does a recruiter look for in a developer who is fresher? And how did you land your first job as fresher, Chris Nova? I don't even know how to answer that. That's such a long story. So if you're new to tech, my advice is to Start collecting as much information as you can. Become a researcher. Become a hacker. Take notes. Be a sleuth. Be a detective. Go and understand what you want to work on, which one you think makes money, the people in your area who are hiring, and target people. Find a place that's hiring and target them. Talk to them. Call them. Understand them. Don't be creepy about it, right? Like, don't, like, get yourself in trouble, but, like, you know, do more than a normal amount of research and understand what they're looking for, and then model yourself to fit that mold. Right, but you read it without doing H2 long. Okay, I mean, we can set it to 0, and we can just set this to known seek -1. Cool. What about the ID? So here in the IP header, we set an ID of the packet set to 0. Okay, let's run this and see what we get. Compile and list. Let's grab a Brave and jump in GDB and RT this. We sent 2 packets and it exited. So you may need to retain that. Do we want to pass it? Can we get the ID, the packet ID? Let's see. So we have context.sniffed IP header. Yeah, we have the ID there. Do we want to pass the ID in as well? What is the ID type? Context sniffed IP ID is a uint16. And then let's add that to our, so uint16t ID there, and then context sniffed IP ID. Cool. So, and then for ID, we'll just pass in ID. Okay. And known sequence -1. There you go. Let's quit. Yes, compile and list. Grab a Brave inode. Oh. Oh my god, where's my GDB command? There we go. RT, that's... Connection reset by peer. On our first... Oh, I know why. Hold on. I know why. Don't worry. Y'all are all freaking out. Nobody fucking freak out. I'll fix this problem. I've got the magic. Making TCPjack L. Grab a Brave. GDB. RT this. Yes. And it broke. Just kidding. I don't have the magic. But I don't know PCAP well enough to be sure. Oh, it's okay. We'll figure it out. So let's do receive message. So this receive message seemed to help out earlier. Cool. RT this. Nope. Oh, let's do RL. Let's grab one of these older ones and see what we get. So you know another thing we can do is we can jump in another, we can try an SSH connection. So let me SSH into Alice. So let's do this. SSH novix at alice.nova. Network. And okay, so there's an SSH stream. So let's make and list. Here's my SSH. And let's GDB. Yeah, and then this connection was broken. So we're breaking something here. So we emit one TTL. We receive a message. We loop. And we get this error. We print F here. An error, broken pipe. So somewhere in this we're breaking. Somewhere in here we're breaking. And I guess we don't even need GDB, so let's do this. Do a TCPjack. Here. Yeah. Emit packet TTL1. It's set to 10. I think TCP header size. Do you mean this file here? Or that value there? I think that's a constant. TCP off, I think. There we go. Maybe that did it, DMA. Maybe it was the TCP header size. Okay, so let's see. So let's go back. TCP header +4. Okay. So node seek -1, ACK is set to true. ID is ID. Let's give it a go and see what we get. Times not plus. Times 4? Okay. That smells like buffer overflow, but I'll trust you. Size of long to unsigned car. Times 4. It's so 4 byte units header is D off times 4. It's not well documented. I'm just gonna keep it with this for right now. Let's just see. Okay, so run list, grab a Brave inode, and run it. There you go. So that worked. At least we're emitting packets now and it's not dropping the connection. Okay, we're still not seeing anything. Okay, so let's try this again. So we're still gonna be tinkering with this 3.3. I guess in theory we should be able to keep doing the same inode, which is good. So this is the world we want to live in. So we emitted 32 packets with a TTL incrementing each time. And we're not seeing any ICMP responses back. Or at least we're not finding any. So we're sniffing the wire on ENP5SO. Let's just if config. And that's this here. Okay, so... Okay, so we finally dropped that connection. What are the chances that Brave is using IPv6? I don't think it would list... It wouldn't show up here, DMA, because I'm reading from ProcNet TCP. I'm not reading from ProcNet TCP 6. Because I don't fuck with IPv6 because I'm American. I eat cheeseburgers. I have serious propaganda problems. And I like hot dogs and baseball. And we don't use IPv6 because IPv6 is for... I don't even know. How was my patriotic American toxic person impression? Did I nail it or did I nail it? Madeline's here. What's up, Madeline? Welcome to the show. IPv6 is socialist. There you go. There you go. And I measure my height using my feet. That's exactly right, says little math boy. Welcome to the show, Mads. How's it going? Okay, so at least we're sending packets without things breaking. Let's keep tinkering, shall we? And just see if we can't get more of these to send. Let's find another one. So we'll grab this Brave broken pipe. Just came from the garden. Awesome. I'm about to go work in the garden. I'm about to go out. I need to go make lunch too for Q. Let's try this one. Nope, now it's dropping our whatever. I don't know, y'all. I'm taking a break. I'm out of here. Cool. I'm all right. First time I've watched you working on the project. What is it for? You can read more about the project here. Please go to this link and click the upvote button if you have not done it already. And there's a link to the blog there. You can go read. That explains what I'm working on. I'm gonna get out of here. So Madeline, go turn on your stream so I can raid you. Let's see. Who are we gonna raid? We can raid Purple Elf, or I'm gonna raid the Space Vixen. Yeah, it feels like a day to go. It's Sunday. We're gonna go do Family Mario Day. All right, I'm out of here, you guys. I love you. Hint for next time: sequence number and next sequence number are different by data length. Thank you, the Roggy. That's good to know. I love you all. We'll see everybody next time. I think you're awesome people. You're wonderful people. You're beautiful people. Keep respecting each other. Try to stay off social media. Drink water. Tell yourself you're doing a good job. Go outside, feel some sun on your skin. Close your eyes and meditate for 30 minutes, and you will feel remarkably better. Eat a nice, ice cold, crisp, honey crisp apple. Try to smile. Try to smile. Remember, the only person who thinks you're as important as you are is you. And that's both a good thing and a bad thing. Try to be a good person. Put some positivity in the world. It's going to be okay. I promise it's going to be okay. I know there's a lot of shit out there. One of the problems is that everybody has to have an opinion. And when people get desperate for dopamine, they start to have more egregious and attention-seeking opinions, which often means those opinions get worse and worse and worse. So you're going to see a lot of bad stuff out there, but it's really not that bad. The mountains are still there. There's still fish in the ocean. There's still warm sand on the beach. It's going to be okay. I love you all. Take care of yourself. I believe in you. Keep your head up. It's going to be okay. We're going to raid the Space Vixen. I'll see you all next time.